Hi friends, welcome back. We're going to be learning quite a bit about the centers of triangles in this unit. So in order for us to do that, you really have to have a good grip on perpendicular bisectors. And a perpendicular bisector is exactly what it sounds like. Remember, perpendicular creates right angles, and a bisector cuts something exactly in half. So if we have a perpendicular bisector, and we have a segment here, it is going to cut it exactly in half, and it's going to create a right angle, just like that. Now, why is this important? Grab your notebooks. We're talking some theorems, and we're talking about definitions and theorems, so I want you to write this theorem down. Let's take a look at our first one. This one says, if a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of that segment. So if you have a point like this point C here, on our perpendicular bisector. Now, how do we know this is our perpendicular bisector? Well, we know these two things are equal, and that's the very definition of bisect, and we're given a right angle right in here, which means it is perpendicular. So this is a perpendicular bisector, and if there is a point anywhere on that perpendicular bisector, then the lines connecting them to the endpoints of the segment are also going to be congruent. So if CP is the perpendicular bisector of AB, which it is, then that must mean that CA and CB are also congruent. So make sure you write that theorem down. That'll be really helpful when we get to triangles. Next one, the converse of that. So let's talk about the converse of that. If a point is equidistant from the endpoints of a segment, then it is on the perpendicular bisector of that segment. So if DA and DB are congruent here, then that means this is on the perpendicular, that D is on the perpendicular bisector, which means that this is the perpendicular bisector of AB. Words are hard. So it's the converse of our perpendicular bisector and saying that things are equidistant from each other. So if we know that this is equidistant, we know these guys are congruent, then it has to be on that perpendicular bisector. Hopefully this helps you understand those better. We'll see you next time.